A satellite dish is a dish-shaped type of parabolic antenna designed to receive electromagnetic signals from satellites, which transmit data transmissions or broadcasts, such as satellite television. Principle of operation. The parabolic shape of a dish reflects the signal to the dish's focal point. Mounted on brackets at the dish's focal point is a device called a feed horn. This feed horn is essentially the front end of a waveguide that gathers the signals at or near the focal point and conducts them to a low noise block-down converter or LNB. The LNB converts the signals from electromagnetic or radio waves to electrical signals and shifts the signals from the downlinked C-band and or Q-band to the L-band range. Direct broadcast satellite dishes use an LNBF, which integrates the feed horn with the LNB of a dish increases as the frequency increases. The actual gain depends on many factors including surface finish, accuracy of shape, feed horn matching. A typical value for a consumer-type 60 cm satellite dish at 11.75 GHz is 37.50 decibels. With lower frequencies, C-band for example, dish designers have a wider choice of materials. The large size of dish required for lower frequencies led to the dishes being constructed from metal mesh on a metal framework. At higher frequencies, mesh-type designs are rarer, though some designs have used a solid dish with perforations. A common misconception is that the LNBF, the device at the front of the dish, receives the signal directly from the atmosphere. For instance, one BBC News downlink shows a red signal being received by the LNBF directly instead of being beamed to the dish, which because of its parabolic shape will collect the signal into a smaller area and deliver it to the LNBF. Modern dishes intended for home television use are generally 43 cm to 80 cm in diameter, and are fixed in one position, for Q-band reception from one orbital position. Prior to the existence of direct broadcast satellite services, home users would generally have a motorized C-band dish of up to 3 meters in diameter for reception of channels from different satellites. Overly small dishes can still cause problems, however, including rain fade and interference from adjacent satellites. Europe. In Europe, the frequencies used by DBS services are 10.7–12.75 GHz on two polarizations H and V. This range is divided into a low band with 10.7–11.7 GHz and a high band with 11.7–12.75 GHz. This results in two frequency bands, each with a bandwidth of about 1 GHz, each with two possible polarizations. In the LNB they become down-converted to 950 to 2150 MHz, which is the frequency range allocated for the satellite service on the coaxial cable between LNBF and receiver. Lower frequencies are allocated to cable and terrestrial TV, FM radio, etc. Only one of these frequency bands fits on the coaxial cable, so each of these bands needs a separate cable from the LNBF to a switching matrix, or the receiver needs to select one of the four possibilities at a time. Systems design. In a single receiver residential installation, there is a single coaxial cable running from the receiver set-top box in the building to the LNB on the dish. The DC electric power for the LNB is provided through the same coaxial cable conductors that carry the signal to the receiver. In addition, control signals are also transmitted from the receiver to the LNB through the cable. The receiver uses different power supply voltages to select antenna polarization and pilot tones to instruct the LNB to select one of the two frequency bands. In larger installations, each band and polarization is given its own cable, so there are four cables from the LNB to a switching matrix, which allows the connection of multiple receivers in a star topology using the same signaling method as in a single receiver installation. A satellite finder may aid in aiming. Types. Motor-driven dish: a dish that is mounted on a pole and driven by a stepper motor or a servo can be controlled and rotated to face any satellite position in the sky. Motor-driven dishes are popular with enthusiasts. There are 3 competing standards: DISEQC, USALS, and 36V positioners. Many receivers support all of these standards. Multi-satellite: some designs enable simultaneous reception from multiple different satellite positions without repositioning the dish. The vertical axis operates as an off-axis concave parabolic concave hyperbolic Cassegrain reflector, while the horizontal axis operates as a concave convex Cassegrain. The spot from the main dish wanders across the secondary, which corrects astigmatism by its varying curvature. The elliptic aperture of the primary is designed to fit the deformed illumination by the horns. Due to double spillover, this makes more sense for a large dish. VSAT: a common type of dish is the very small aperture terminal. This provides two-way satellite internet communications for both consumers and private networks for organizations. Today most VSATs operate in Ku-band. C-band is restricted to less populated regions of the world. There is a move which started in 2005 towards new Ka-band satellites operating at higher frequencies, offering greater performance at lower cost. These antennas vary from 74 to 120 centimeters in most applications, though C-band VSATs may be as large as 4 meters. Others: individual dishes serving one dwelling, direct-to-home, collective dishes, shared by several dwellings, satellite master antenna, television or communal antenna, broadcast distribution, automatic tracking satellite dish, General Electric satellite dish for DirecTV satellite television, Sky Digital mini dish, satellite dishes installed on an apartment complex, WWEHD trucks in a parking lot, the backside of an old C-band Big Ugly dish, satellite dish showing the pole, mount, motor, and structure of the dish, satellite dish at a hut in East Timor. Ad hoc: the dish is a reflector antenna, and almost anything that reflects radio frequencies can be used as a reflector antenna. This has led to trash can lids, woks, and other items being used as dishes. Coupled with low-noise LNBs and the higher transmission power of DTH satellites, it is easier to get a usable signal on some of these dishes. History: parabolic antennas, referred to as dish antennas, had been in use long before satellite television. The term satellite dish was coined in 1978 during the beginning of the satellite television industry, and came to refer to dish antennas that send them or receive signals from communications satellites. Taylor Howard of San Andreas, California, adapted an ex-military dish in 1976 and became the first person to receive satellite television signals using it. The first satellite television dishes were built to receive signals on the C-band analog, and were very large. The front cover of the 1979 Neiman Marcus Christmas catalog featured the first home satellite TV stations on sale. The dishes were nearly 20 feet in diameter. The satellite dishes of the early 1980s were 10 to 16 feet in diameter and made of fiberglass with an embedded layer of wire mesh or aluminum foil, or solid aluminum or steel. Satellite dishes made of wire mesh first came out in the early 1980s, and were at first 10 feet in diameter. As the front-end technology improved and the noise figure of the LNBs fell, the size shrank to 8 feet a few years later, and continued to get smaller, reducing to 6 feet by the late 1980s and 4 feet by the early 1990s. Larger dishes continued to be used, however. In December 1988, Luxembourg's Astra 1A satellite began transmitting analog television signals on the Ku-band for the European market. This allowed small dishes to be used reliably for the first time. In the early 1990s, 4 large American cable companies founded Primestar, a direct broadcasting company using medium-power satellites. The relatively strong Ku-band transmissions allowed the use of dishes as small as 90 cm for the first time. On 4 March 1996, EchoStar introduced Digital Sky Highway. This was the first widely used direct broadcast satellite television system and allowed dishes as small as 20 cm to be used. This great decrease of dish size also allowed satellite dishes to be installed on vehicles. Dishes this size are still in use today. Television stations, however, still prefer to transmit their signals on the C-band analog with large dishes due to the fact that C-band signals are less prone to rain fade than Ku-band signals.